Now, our today's topic is relative density. Now, under this topic, we are going to define relative density. We find formula for finding relative density. We determine whether relative density has unit or not. Then we use it to determine which object will sink in water and which one will float in water. Now, when we say relative density, the first thing you need to understand is this relative. So which means to compare two things together. This is not the first time of coming across this relative density. We come across it under relative motion, which means to compare the motion of one object or one body in one frame to another frame. Then we still come across it under relative humidity, which means the humidity at certain temperature with normal temperature. Now, for the sake of today's topic, which is relative density, which means to compare density of two things together. Out of these substances or material that we have, we must have one as reference. But because of the nature of water will serve as our reference point. That is, because we can easily get it and we can easily buy it at cheapest price. So water is used as reference substance. Now let's define relative density. To define relative density, we say relative density can be defined as ratio of density of substance to density of water. Therefore, relative density is equal to density of substance over density of water. That is the ratio of density of substance to density of water. Now, this is not only way of defining relative density. We can still define in terms of what? Masses. So in that case, the relative density will become the ratio of mass of substance to mass of water, a mass of equal volume of water. Take note, when you are defining relative density in terms of mass, you must put equal volume of water there. That is the ratio of mass of substance to ratio of mass of equal volume of water. And that is not only way. We can still define it in terms of what? Weight. So that will give us relative density can be defined as a ratio of what? Weight of substance. Weight of substance to weight of equal volume of water. Take note, in the case of mass and weight, you must put equal volume of water there. But if you are defining it in terms of density, it just gives you density of substance to density of water. Now, we can still define it in another way. We can define relative density as what? Ratio of loss in weight. Loss in weight in substance, that is liquid, over loss in weight in what? Water. So these are the four major ways of defining relative density. Now let's see whether the relative density has unit or not. Now let's take this formula for instance. If our density is in gram per centimeter cube, it means this place we are going to have gram per centimeter cube. Then this one we are going to have gram per centimeter cube. So this will cancel this, so that relative density has no unit. And if you are taking this formula, this one will be in gram or kilogram, while this one also will be in gram or kilogram, which will later cancel each other, which shows that relative density has no unit. Now, let's go to the next subtopic, how to use relative density to determine whether an object will float or sink in water and which percentage of that object will float or sink. Now, from this density of these substances, you can easily determine which object will float in water, which one will what? Sink in water. If you look at it, density of alcohol is 0.81, density of benzene is 0.90, density of ice is 1.92. Then density of water is 1. They are in gram per centimeter cube. The way I'm going in essence is this. All this one, that their densities are less than density of water, they are going to float in water. Why all this one, something like milk, blood, magnesium, aluminum, iron, gold, all of them, they are going to sink in water because their density is greater than density of water. While this one, alcohol, benzene, and ice, they are going to float in water. Now, let's go and use relative density to determine which percentage of this, all this one that they are going to float, which percentage of them will float in water. Now, in that case, we first of all determine their relative density. We say relative density is equal to density of substance. Then let's use ice as an example. Density of ice over density of water. Therefore, relative density of ice is equal to 0.92 over 1.00. So which will give us is 0.92. Does not have units. So this is relative density of ice. Then if I want to know which percentage of ice will sink in water and which percentage of it will be on top of water, in that case I will convert it to percentage, which will give me 0.92 multiplied by 100 over 1. So at the end of the day, I will have 92%, which means if you drop an ice block inside water, 92% of which will sink, while the rest will be on top of water. So it will, in that case, we say it's partially what? Immersed in water. So we can still do that for other subjects and determine which part of them will sink and which part of them will float. So that will be the end of today's topic. So we'll meet next time.